Welcome back. In this video, I'll discuss integer overflows and underflows in Rust and how we can prevent them. So, the integer overflow and underflow occur when a calculation produces a result that is too large or small to be stored in the data type. For example, if an unsigned 8-bit integer data type is used, the maximum value it can hold is 2 to the power of 8 minus 1, and the minimum value is 0. If calculation produces a result larger than this maximum value or lower than the minimum value, the result will underflow or overflow. This can lead to severe logical errors in the program, and in case of Rust, it also leads to panics. Rust catches integer overflows during runtime if a program is compiled in debug mode. Instead of letting the value overflow or underflow, Rust throws panic. And in this scenario, panic is way better than letting an incorrect value being used within the program. Value might lead to calculation mistakes, which can cause severe logical errors. However, integer overflows and underflows are silenced during runtime if a program is compiled in release mode. To prevent it, we must always have overflow checks enabled in cargo.toml through overflow checks true. In this example, we just simply have a function called underflow, which just subtracts B from A, and we just get a number from a user and call underflow with the number supplied by a user and 6 as a B. And in this example, we first just use basic cargo.toml, and we compiled our program in release mode without any overflow checks. And we entered 5. So as you may have guessed, 5 minus 6 is minus 1. But since we're using unsigned integer, it underflowed to 255, which is U8 max. Then we compiled the program in release mode again. But in this case, we have overflow checks true enabled in cargo.toml. So instead of actually returning to 55, we got a panic saying that we attempted to subtract with overflow, which is way much better. All right, so let's move to other integer overflow prevention techniques. The first one is checkmats. Checkmats, instead of returning the value itself, it returns an option type, which we can then unwrap gracefully. It basically converts unrecoverable error to recoverable one so that we can then match on some or none. And if we receive none, means that we got an integer overflow or underflow. Now we can gracefully handle that case if we got none back. Instead of having A plus B, we will have A dot checked at B. So that's a syntax. We can use checked sub, checked diff, checked mul, and here is the full list that you can check out later. So the second way is saturating math. In this case, value is just returned within numerical bounds if we got overflow or underflow. So in addition multiplication, if the type is U8, upon overflow, we get 255, which is U8 max. And in subtraction division, in case of underflow, we get uint 8 min, which is 0. So let's see an example. In this example, we just have two functions, overflow saturating and underflow checked. Underflow checked just uses checkmats to subtract B from A, and overflow saturating uses saturating mats to add B to A. So we basically just have underflow checked, which subtracts 6 from 5, and then we have overflow saturating, which adds 10 to 50. And since our type is U8, in both scenarios, it's gonna either overflow or underflow. In this scenario, it's gonna overflow. In that scenario, it's gonna underflow. But as you can see, since we're using integer overflow, underflow prevention techniques, here when we get underflow, we're going to receive none. So we can just check if value is none. And in that case, we can just print that underflow is occurred and exit. And here is actually a nice way of using unwrap, which I mentioned before. If we have all safeguards, why not just use unwrap? We already handled none case here, so we could just easily unwrap it, since if it's none, we're going to just exit the process here. And in the second scenario, when we add 10 to 55, we're going to normally receive an overflow. But since we're using saturating maths, we will just get 255 back, which is U8 max. All right, so let's go to the code and see those examples in action. All right, so let's start with the first example. Here, as I explained before, we just have underflow function, which does a minus b. We get a number from a user, and then just supplying the number as an a to underflow function and putting 6 as b argument. And yeah, let us run it first. Okay, let me just move here. And obviously we're going to run it in release mode to show you how it underflows. Okay, let's input 5. So it's going to be 5 minus 6. So it has to return 255. Yeah, as expected, it returns 255 since we compiled it in release mode and we don't have any runtime checks in the release mode. So let me just clear everything and add overflow checks to cargo.toml. So yeah, let's do profile release and then overflow checks true. Oh, it should work. Let me just recompile everything. Okay, let's enter 5 again. Yeah, as expected, we got the panic back, which is a lot better. Attempt to subtract with underflow. All right, so let us move to overflow prevention example. Again, we have just 2 functions. First function does a minus b using checked maths, and the second function does a plus b using saturating maths. So we have just underflow checked in here, where we subtract 6 from 5, and here we do 250 plus 10 in using saturating maths. Then we print the value 2, which hopefully is going to be 255, because saturating maths returns the maximum value that the type can hold. In this case, it's U8, so it's going to return U8 max. And in this scenario, we get an option back and we are checking whether the value is none. And if it's none, it means that there is underflow. And we just print the message underflow occurred. Please try again and exit the process instead of panicking. And here we just print the value back here if we get something else. So if we won't get any underflow, we can just print the value and wrap it, since we already checked the none case here. So let me just run it. Cargo run. Let me just change it to flow prevention release. Okay, as expected, we get 255 in here from overflow saturating. Since 250 plus 10, it's going to be an overflow. And since we're using saturating maths, we get 255 back. And in this case, we do 5 minus 6. And since it's going to be an underflow, we check that it's none. And since it's underflow, we just print the message underflow occurred. Please try again. All right, so that's all for this video, and I see you in the next lecture.